the intonation and the features of the vocal cues. And the other is about using LLMs as subjects in experiments. So let me start with the first. The first one is a collaboration with Shanshan Zhang, who is at Wuhan University in China, and Matthew Gomez at CGU. And basically what we're asking is, can just the voice predict cooperation and deception in high-stakes real interactions? So again, we're looking at simply the voice, not what people say, but the voice features. As we all know, there has been a vast amount of literature, both theoretical, but mainly experimental, on pre-play communication and how it affects behavior. So what we know, especially in strategic environments, that talk is informative, especially when interest of players are not aligned. So when we have pre-play communication before making a decisions, then a lot of it's just cheap talk, especially when we have the interest of the players not aligned. But what we see is that in reality, behaviorally speaking, communication does have an effect on behavior, even when it's not expected to have one, theoretically speaking. And some behavioral economists have said, okay, what's going on? So people have talked about issues with communication just creates this feeling of empathy, guilt, social closeness that affects your decisions. And a lot of other economists have been looking at, okay, given that this pre-play communication does seem to affect behavior, what is it about the communication, the talk, that people actually can tell us whether the individuals are going to, for example, cooperate in a prisoner's dilemma or are going to be deceptive? So there's some study by Sarah Garcia, for instance, that looked at deception and communication. And she finds that vagueness is used as a strategy when inconvenient truths cannot be completely hidden. And there are other authors like Turkmut et al. That looks at the behavior before playing a game, a prisoner's dilemma game, that statements of conditionality and implicitness seem to be associated with lower likelihood of cooperation. The point is that there has been some attempt to kind of look at what it is about the communication that is predictive of how people are going to behave. So what we are doing is we're looking not at what people are saying, but basically the nonverbal aspects of communication. So we know that a large percentage of the information is contained in nonverbal cues, such as facial expression, posture, vocal cues. And in fact, there's some estimates that 70% of what communication is exactly that. Not what we say, but how it's said. But what's interesting is that humans are generally not good at understanding these cues. And so what's new now is that we have these machine learning techniques that allow us to actually identify these cues in a seamless and now inexpensive way, if we have open source, to kind of see what it is that the nonverbal aspects of communication are telling about intention, or what are the telltales of behavior. And one of this is voice. Now, we're interested in voice. Many people have looked, for instance, facial recognition technology, skin conductance, and other ways to kind of gather information about, to predict potential behavior, different behaviors. But we're interested in voice for many reasons. One is it's completely ignored in behavioral economics. I haven't seen a single paper on the analysis of voice and behavior. There are papers in psychology, and there are papers in criminology as well. But voice is unique as one's fingerprint. So through voice, you can identify age, gender, and body size. So if you're doing survey somewhere and you're able to do the survey like with phones, you can already know at least the gender and the age of the individual, just by not even asking a single question. So also voice signals effective and internal states. And going back to the application of using like phone for surveys, you can actually gather information about the psychological state of individuals. There was an idea we had a few years ago with the World Bank that used this phone technology to gather survey data, that one can actually assess the level of background violence in a place by just assessing the voice of the people who are being surveyed. So it gives you a lot of information. It's difficult to fake. So in strategic environments, when people are like, talking about, oh yeah, I'm going to cooperate, trust me, or I'm telling the truth and so on. Although you could manipulate language itself. So you could, reduce your vagueness. If vagueness is a telltale of deception, you could actually manipulate how you say things. What it's difficult to manipulate is the voice, because they're actors, very good actors can do it, but generally speaking, it's difficult to fake, and may actually give you information about intent that an analysis of the text would not. But the most important thing is that it's easy to obtain. It's non-intrusive. So if you're doing analysis of eye tracking or facial recognition or skin conductance and all that, all are very intrusive. And whereas the voice is not, and it's easy to capture. So, and finally, one thing that we are interested in is whether there is transferability. So if we can identify features of the voice that are predictive of behavior in one environment, can those features actually predict behavior in a different environment? With text, simple text analysis, you can't do that because the conversation will always be about a specific context. Okay, so basically the research question is, can we predict the intent to cooperate and deceive from voice alone? And one thing that we do is we're looking at high stakes natural environments. As I mentioned before, there were some people in the past who looked at analysis of the voice in very constrained lab environments. And especially in criminology, there is a vast amount of literature because they want to see, okay, how can we help the CIA or the police to identify the liars? And so they are trying to maximize predictability, and they have these laboratory settings and multimodal approach, meaning that they look many things. They look at the voice, they look at movement, they look at skin conductance, heart rate, everything. So what we're just interested is in voice, and we're interested in environments that are natural and high stakes. And we also would like to identify specific acoustic features that will help predict behavior, especially cooperation and deception. And this is because there is an application now that you can actually modify features of the voice in developing voice bots, for instance, that people feel that are more cooperative when you're interacting with a voice bot. What are the features that will make it be more cooperative? And so we want to see specific what features, instead of like just maximizing predictability, identify what are the features that are more helpful. So again, it's different from previous research because others use scripted, controlled, and low stakes. And there is a study with one of our data set that is a multimodal approach, again, looking at maximizing predictability rather than saying, okay, let's look at voice that is easy to extract, easy to analyze, how predictive is it, and what features are important. Okay, so we're also looking at transferability. So in our data set, we look at high stakes, real interactions. And you're probably familiar with this TV show, the British TV show called The Golden Balls, which is basically a prisoner's dilemma game with pre-play communication. And there have been papers in economics literature on this. And again, one of them is Turmeric et al. That they find that conditionally vague language revealed the intention not to cooperate. So what we're doing is I'm just going to play one part of it. So you have the golden balls. So we're looking at.
You each have a golden ball with the.
You can see there is.
Half is more than I thought I would go away with today. So I am more than happy to split with you if I can trust you to do the same with me. Oh, I got. You each have a golden ball
And I'll
with the
stop
word
it.
flip.
So again, so you can see the conversation that these players have, and they're talking, they're saying stuff, but we're only extracting acoustic features of the voice to see if that's predictive of whether they're going to steal and or split, right? So and for the second data set, this actually data set is publicly available, and there is another data set that we use, which is the real life trial, which is also publicly available. And this is basically real court trial depositions by witnesses and defendants. And they are gathered at you can access them from the University of Michigan data set. And so this is
from conversations from what Jody telling me that he had talked to other girls even when they were supposed to be together.
Okay, so there is well, we're able to identify whether the individual's account was truthful or not based on the police reports and the final trial outcome. Somebody said that that's not exactly a reliable way of saying whether it was truthful or not, but that's what we have, and that's what others also have used for identifying what can predict deception. Okay, so so what we do is we take these video clips that I just showed you, and before, we can do all these things now because they are publicly available open source tools that before we didn't have. And so we can take the video clips from the golden balls and real life, then we extract the audio clips, and we use an extraction via Audacity. This is publicly available. You could use this tool. Everything that we have is in our GitHub repository so that people can perhaps replicate. And then we from the audio clips, we acquired voice features. And we use Python. Before, we didn't have this package, Parselmouth, that allows us to do this analysis of extraction of voice features. So voice features include, pitch, intonation, and harmonic to noise ratio. There are different, the formats. So all these features that make the voice, the characteristics of the voice can be extracted through this package. So what we do is, after extracting the features, we look at machine learning. We use random forest and decision tree to see. We train with 75% of the data is the training set, and the 25% is the test set. And we look at how good are our features, the voice features, at predicting either cooperative or deceptive behavior. So we use the decision tree and random forest. Decision tree, so there is a trade-off between interpretability and accuracy in these models. Decision tree is always a good one to start with because it's simple to understand and interpret. So you can visualize, and it makes it kind of it's not kind of like a black box the way that a random forest is. And the random forest is just an ensemble of decision trees, and it's a lot more accurate. So we're just looking at accuracy. We just look at this random forest, and we see that for the case of the golden balls, so we're looking at how good is just the features of the voice that we extracted, not what people were saying or anything like that, at predicting cooperation. And we see that compared to the naive case, we have an improvement of about 9 or between 8 and 9%. For the real life trial, we have very high accuracy, between 76 and 79% for females and males respectively. And this is just by looking at the features of the voice. So we are able to have a pretty good accuracy. And so we also, because we use this random we use decision trees, we identify what are the features of the voice that seem to be important. So we used also them to run this logic regression to see how they are correlated with the probability of cooperating and being deceptive. And for the golden balls, we find that higher pitch of male voice is positively associated with cooperation. And this is the harmonic to noise ratio. This is basically how deep the voice is. A higher HNR means that it's less deep, like older men will have lower HNR. So higher HNR, which is actually a very good estimate of age for males, is negatively associated with cooperation. With respect to deception, we also find that pitch is important. Higher pitch is positively associated with deception for both females and males. Higher intonation is negatively associated with deception for both genders. And also for males, higher HNR is negatively associated with deception. So what we are able to do is not only show that that voice, especially in deception, is quite accurate at predicting deceptive behavior, but also which specific features of the voice seem to play a role. Okay, so just to summarize, so we have, in terms of cooperation, just the voice alone, features of the voice alone, improve accuracy of predicting cooperation. The voice alone significantly improve prediction of in the real life trial for deception. And what we did too is we said, okay, what if we add text sentiment? So we use some way to identify whether we analyze the text to see if it had positive or negative sentiment, and that had no improvement in the accuracy. So we find finally that pitch, tone, and HRN seem to be the key features of the voice that are affecting deception or cooperation. So remember that I mentioned that, well, we have two data sets, so two different contexts. In the case of deception, we could say that individuals who actually were trying to, saying, oh, I'm going to split, but later still they were being deceptive. So we want to see if the voice features extracted in one setting could predict deception in a different setting. And so this transferability is something that we were unable to find for our data. And so what is interesting is because what seems to be happening is people's pitch and intonation and everything does seem to adjust to context. And if you think about it, it does make sense. In the case of the golden balls, they are in a game, so in a TV show, and there's music and there is other things that will affect the voice. Okay, so why are the implications of this? Again, so we would like to push the study of the analysis and study of voice in behavioral economics. It's completely understudied. It's simple to collect. We have now tools to analyze voice data, has applications, is unintrusive and easy to collect. There's applications for law and justice, business and commerce. Again, the design of the voice votes identify features that seem to make the voice vote to have more cooperative intent. We could fine-tune the voice features. Fine-tune important announcement. I talked to somebody at the Federal Reserve Bank, and they're saying that every time the President Powell makes an announcement, the market moves. So, they are very careful about the words they use, but they had not quite considered the possibility of the non-verbal aspects of that communication. And so also it's maybe applications. I know that there's some applications for flagging potential deception. Deception is very costly to organizations. So if you're hiring somebody to be positioned in a key, like you see in private data or like social security numbers and financial data, you want to have a good way to flag potential deception by those employees. Also, I think that the application that I find I'm more excited about is flagging self-reports in surveys, because there might be some measurement error, and you don't know whether people are really deceiving in answering their questions in surveys or not. So it would be a way to kind of flag them. And again, you could use voice as data in hard to reach areas. If one is unable to do surveys, as in the example I gave about the World Bank, they were interested in doing this distribution of phones in Boko Haram areas that are very dangerous to send surveyors. And so you could actually use the voice as data to kind of learn more about hard to reach areas. So I'm going to move to the second paper now. And this one is looking at using large language models, basically, to create personas that are representative of populations that are hard to reach. So for those who are not familiar with weird means Western, educated, industrialized, rich, and democratic. So that's most of the Western world, and most of the people that we use in our behavioral studies are representative of that. Even in developing countries, I'm from Bolivia, it's a developing country, it's a poor country, but student subjects are weird. So we're interested in seeing, okay, can we create personas, AI personas that will be subjects that represent non-weird populations, and then we can unleash them playing behavioral games, and through their decisions, they can reveal latent preferences that are unknown because these groups are hard to reach. Oh, by the way, this is collaboration with students, undergraduate students at Pitzer College and Pomona College. Okay, so again, everyone is by now familiar with large language models like ChatGPT. And so basically they can generate, as we know, human-like text. And they use a vast amount of data that they're trained on, hundreds of billions of text data, even trillions, that will give us kind of prediction based on the previous sentences that you give. It will give you a statistical prediction of what's the most likely next word. So for example, if you have once upon a time, then once upon a time there was a kind king, or once upon a time there was a princess. And so it's based on the context that is fed. Will give you a statistical prediction of what's the most likely word to come next. So what's new about these, relatively new about these models, is that you can create personas. And perhaps some of you have already done this. Like if you are writing a paper and you're like, oh, I want the AI to help me with that sentence, you'll say, oh, you are a helpful research assistant, helping me write a clear sentence for an introduction to a paper. So you basically narrow down what the agent is going to sample from to respond to your question. So I did, for example, I created a persona, Adam Smith, and I asked this persona to respond to every question from the perspective of a classical economist. And so this is just an example. I say, how would you handle a difficult customer? The generic ChatGPT will give you the generic answer. However, this bot that I created, it will, it emphasize fairness, long-term success, and reputation of business. Now, the response is really long, but you could tell that it is taking the Scottish, kind of classical economist response. So this is just to show you that we can use technology that is available to create personas that could be participants in our experiments. So we could use LLM agents as agents that can respond to experimental instructions. And it is similar in spirit to the idea of using agent-based modeling. So basically you could use agent-based modeling, but for agent-based modeling, you have to pre-program behavior. But in this case, you don't pre-program the behavior. You just tell the AI to sample from specific sources and to answer questions based on that. This idea Actually, as far as we know, the first person who came up with this idea was John Horton, and he coined this agent Homo silicus, which is basically a computational model of human behavior. That's what the model predicts is statistical probable. And so he has this paper, it's a working paper in BR, and basically, proposes the use of large language model simulating economic agents. So we're doing the same, but we have a big important differences from his approach. Number one, what we want to do is we want to create populations that are hard to reach. The reason why we're interested in that is because if we kind of follow what Joseph Henrich says, is that with behavioral experiments, we're just getting a small glimpse of human nature because we're using weird people. Even if we recruit from Bolivia, they're still weird people. But these non-weird populations have in them features of human nature that are being ignored. So to understand the evolution of human nature and to understand, the nuanced behaviors, we need to have more information about how non-weird populations behave. The problem is that it's hard to do this. Not only is it expensive to go to, these are a group of Aceh, this is the Hadza. It's not only difficult to reach these individuals, but it requires specific skills. And there's a concern about, if you do experiments in these areas, if we are concerned about experimental demand effects in the lab, you can imagine how this is in tribes like this. My sister has worked with the Chimane in Bolivia. It's an indigenous group. And so it takes years for them to develop kind of trust with the researchers, just the biologists, environmentalists, and even people who are not testing behavior. There's still an element of this, the effect of having the researcher there and how it affects their behavior. So what we're interested in is to create an artificial agent using LLM with decision-making profiles modeled after the specific culture. And we're interested in what can these agents reveal about preferences and behaviors of non-weird populations. Okay, so we're taking we're going to start with a kind of test our model with something with experiments that have been done in the field. So we start with the endowment effect, and there's a paper published in the AER by Apicella and her co-authors that looks at the endowment effect, which is the tendency to value possessions more than non-possessions. And they're doing it with the Hadza. The Hadza are Bushmen in northern Tanzania. And they, in generally speaking, they show that there is no, or a lot of less endowment effect in the Hadza population. Okay, so what we were going to do is we're going to create a Hadza LLM. So for that, what we do, and it's different from other approaches, is we use a LangChain framework. LangChain is basically an open source framework. And so what it does, it allows you to combine large language models, like ChatGPT, with external data. So it basically is a platform or a framework that allows you to use these web crawlers and allows you to actually, it supports like PDF text extraction. So you can feed this LangChain, you could feed information that integrate information with the ChatGPT. Okay, so this so we basically, what we like to say is what we created is a LangChain Hadza. So the other thing that is nice, this LangChain can also have prompt chains. So the LangChain will prompt itself to answer questions. So if you are interested in creating a profile of the Hadza, it will create a chain of prompts to ask itself. So you don't have to continuously prompt and ask it. So that's how what the LangChain architecture allows you to do. And we can also run them with chat and completion models. Chat are like ChatGPT, completion models like GPT-4. And so this will be designed to maintain a conversation, whereas this was are in a way are completion models, and they might have a better ability to extract nuisance information about the group. So there could be trade-offs between these different models. And then we run them in experimental setup. So again, so the main thing is the building of the cultural profile. And so I'm gonna show you here gonna play this. You're gonna see a little bit how this is done in Python, how this works in terms of creating the profile. So here's the part that I guess is very interesting, which is the agent executor, and it's creating the chains of action. So I don't know if you noticed, but it has the chain of questions, and once it reaches a specific kind of criterion, it stops and then gives you the profile of the group. It's also, all this is also in GitHub, and it's available. Okay, so we have 3 prompts. So we have the system prompt, and the persona is created by this lang chain, and then we ask the LLM to say that they're a member of the tribe with a profile created. And then we have an experimental prompt that specifies the decision environment, and this task prompt that specifies the choice set. So the framework is already out there, that you can change the experiment prompt to whatever experiment you want. And then, sorry, I don't have my mouse. Okay. Okay. So what we have here is what the output. No, there's so if you know, when you run these things, so the lang chain was linked to a server Google search. So it's looking at the internet for information. So I'll go back to this point. But another thing is that these models, you can vary the temperature. As you have experienced many times, like these models can hallucinate. So the higher the temperature, the more hallucination there's going to be. And so we look at different temperatures to come up with, how many times the model will reject or exchange the biscuit. And we see that for the Hadza lang chain Hadza, with the GPT has about 50-50%. And so this yellow frame represents the estimated the rejection rate and the confidence interval based on Apicela's work. So it's very close to what the GPT-4 Apicela found. And then we did the same again. You just changed the experimental prompt for the ultimatum. Now, Henrik has done a study with the ultimatum game, and so we have data from the field studies, the ultimatum game, and here we have the chat model gets very close to what Henrik observed. So basically, in the case of Henrik, so he did a study where he imposed an experimental imposed low offer of 20%. Okay, and the Hadza rejected only 31%. So we are kind of this one is close to what he found. So in this case, in the prompt, we say you were offered $2, kind of to mimic the experimenter imposed low offer that Henrik did in his paper. Okay, so what we can do with this is we can create a different tribe. We created the Hadza lang chain agent. We also created an Ache lang chain agent. Ache is a tribe in Paraguay, and no, Henrik has done studies with the Ache, but on the ultimatum games, but nobody has done the endowment effect with them. So we could look at the endowment effect for the Ache. And so although, Henrik says that there are differences in the ultimatum game between Ache and the Hadza, there's no endowment effect on with the Ache, but we do see that there's a difference in our lang chain or homosilicus, Ache and Hadza. So the takeaways, we created a lang chain agent, a type of homosilicus representing the Hadza. We tested the endowment effect and the ultimatum as proof of concept, and we showed that lang chain agent can reveal latent preferences of population living in small-scale societies that are hard to study, giving a more complete picture of human nature. Now, the problem is that we're using Google search, okay, for our lang chain. And so the problem is that there are some tribes for where there is nothing available. So we did research, and there are the Tsuatscha, that nobody has studied the Tsuatscha. So there is very little information about certain tribes. And of course, your model is going to be better the more context there is to fit the model. And so what we found is for these kind of non-weird populations, there is a database, which is the Electronic Human Relations Area Files, that is a repository by Yale University that works from the turn of the 20th century. And this is really fascinating because in principle, what you could do is you could aggregate. So researchers today, we aggregate information mainly that is more recent. In coming up with hypotheses, smart, really good people, successful people like Joe Henrik, he is, and others, they're, gathering most information that is actually most recent. But I wonder to what extent, like, all the information from the turn of the century about these groups is somehow not ignored. I mean, I don't know. But what we can do with these models is we can go back in time. And so the lang chain can be fed text and PDF and stuff, and then you could inform it with timeless information about specific tribes. And so that's our next step, what we're working on. And to end this talk, so there is another application, which is that we could use this homosilicus, and there's something that we believe has a really interesting application, which is we could help pilot experiments. So I was talking to somebody who did a study on what's interesting doing an intervention with in India with in-kind transfers versus cash transfers, and how people are going to react to those different kind of intervention. And so if you could use this lang chain agent, create a profile, and run a simulation of your intervention before implementing it in the field, and you could get an idea of how they're going to go. I mean, in principle, that might be a good application of these models. But also there is the point that AI can help econ, but econ can help AI. So what my students are working on right now is looking at using experimental games, to test the LLM architectures. So the same way that in neuroeconomics, basically the neuroscientists were really excited about neuroeconomics because we could use our little games to help them identify areas in the brain responsible for, let's say, cooperation, deception, and all that. We could do something like that to use economic games to uncover what these agents, LLM architectures are like. Okay, so that's it for my talk.
Thank you very much, Monica. The floor is open for questions. So in the audience, if you have a question, please just raise your electronic hand. we have a question from our president, Vera. I believe you can unmute yourself.
Yes. Well, thank you very much. I'm trying to start my, oh, I can't start the video unless you let me. Leo, please. Okay. Well, thank you very much, Monica. Very interesting papers and the research and all. And also, I'm Latin American too, so I'm particularly happy to hear about more non-weird research being conducted. And I have two questions. One is a little one regarding the first study. I was wondering about the effect of a smoker's voice, because that changes a lot, particularly for women, for example, when you have like an older woman who has smoked for a long time, it sounds like a male, actually. So, you know, how would you work for that? Do you plan for it or something? And the second one, about the AI, the use of AI, do you believe that some kind of curation of the internet information that is available would be one of the directions to get more accurate information for all these models? Like, you know, a pre-selection of, because the internet is, you know, a universe, anything goes. So a pre-selection of the most relevant data, really. Would that help, in your opinion? Thank you very much.
Yeah, thank you for the questions. Yes, indeed, like the smoking or some problems like with people, some have some pathologies with the voice do affect the voice. But the voice actually, I do not know. People have studied, to be honest, you know, what the effect will be of smokers. We cannot, we have no idea if the people that were in the trial depositions, the witnesses and the defendants, or the people who were in the game show smoked or not. But in general, it's very hard to change the voice. Like people try through surgeries. It's a complicated surgery. People who have voice issues. I think Scott Adams is an example of somebody who has voice issues and went through surgery. Robert Kennedy is another person. It's a very complex, it's an instrument, really, a complex instrument to change. But there's no way with the data we have that to know if they're smokers or not. But yeah, so the people who do this kind of lab approach, so they create these right conditions where the people are actually in like voice labs where, you know, voice is, everything is, because they want to really fine tune come up with a widget that will actually, you know, test whether the individual is telling the truth or not. And it's for applications for police and justice and I guess the CIA or whatever. But they do put them in very controlled environment, and they probably do have data on whether they smoke or not. And some of the data, because they are publicly funded, they're public data, so one could potentially look at the data sets from people who have done studies on voice. And for the second question, yeah, so the problem is that with the non-weird populations is that there is less information, so we have to try to feed the model more information. There just isn't enough. Yeah. So.
Okay, thank you.
We have another question from the audience. Cancelevi, if you want, please ask your question.
Can you hear me?
Sure.
Sorry, I apologize. I don't have my video, so I'm just going to be a voice. Is that okay?
Sure.
First of all, thank you for both presentations. They were really great. They were really fun. I have two questions. One, a rather technical question, is about how do you augment the existing LLM with the knowledge base, like that you retrieve from the internet using LangChain? Do you simply use it as a knowledge base with vector embeddings, or do you use any type of RAG techniques to?
Yeah.
And then the second question, before you continue, Is it possible just to prompt LLM to act as a non-weird population and then just observe the behavior in such manner rather than feeding with this additional information that you acquire from the internet? Like say, act as if you're someone from, I don't know, country X, and then with a lower temperature, and then ask it, and then acquire data that way without any additional knowledge that you acquire from the internet.
Okay, so that's a great question. Thank you. No, we just use vector embedding, although the computer scientist in our group is going to try the RAG next. For the second question, yes, that's a really good question. I mean, yes, I think that Horton is actually doing that, right? So he's just looking at what will the LLM say and behave, how will it behave, rather than building a persona. So I think that's really interesting too. Is that was your question, right? So you can just ask the LLM, and the LLM without kind of generating a framework for creating the persona. Yeah, I think that's an interesting way of. I mean, now it's wide open. Now there are a lot of different models that they're not only. So you have Cloud, you have Bard, but there are also, as far as I know, there are like hundreds of different models that can be tested. So you could use these, prompts, these economic experiments to test the models.
I'm asking it because I'm also wondering how representative is an LLM like GPT is to all these different populations that are like not West. Like without any additional information, are they capable of actually representing these populations? I think that's a question on its own too that is valid.
Yes, very nice question. Very interesting. Yeah, it's a good question. I don't know. It's a good suggestion for as a follow-up, just to see that.
Okay, I believe Leo has a question.
Thanks a lot for the talks. Super great. I enjoyed that a lot. Can I ask, to what extent the data that you have is really weird? Is this data really coming from the tribes, let's say the Hadza, or is it a description of weird people of the Hadza? So if most of the written word comes from, say, the US, writing about the Hadza, so is maybe there's observer bias in there integrated? Is that an issue?
Yeah, that's a really good point. Exactly. So at least we can go back in time because of this repository that has data on ethnographic data all the way to like early 1900s, and there was great interest in the early 1900s. Remember, they found Machu Picchu, and there's huge amount of interest at the turn of the 20th century on ethnographies and stuff like that. So, but what we were right, so we will have to do a more kind of cross-country gathering of information, including researchers that may have written in their local language, which is at this point ignored. But this is what we can do with new technologies. Definitely, I mean, you could access those writings if there are any, and then translate them and feed them to the model. So in fact, it will. You stop kind of relying on just one perspective. You can go back in time and cross country. That's the great potential of the technology.
Going back to the first study you presented on voice, I mean, you mentioned, I find it fascinating, but you mentioned that there is a problem of transferability. And in all this kind of literature, there is some even more general problem, which is overfitting. Whenever you try to apply machine learning methods to a data set and now try to do prediction to a slightly different setting, we find out that the lack of structure hits this overfitting. So do you think that it's related to that, or it's a problem more particular of voice and intonation and adaptation of voice to the situation? What's going on?
That's an excellent point, Carlos. It's for us it's both, but my intuition that if we can kind of tease out which one is causing more of a problem, if we could do that, is going to be, I think the voice is, I think that as we change our behaviors to the context, we have this hard to control that are non-volitional changes of our voice and everything to the context as well. And so it's really hard to do this transferability because in one environment, a high pitch might be the socially acceptable today, like if you're in a party and but in a different context, that's not, right? And we non-volitionally adjust to that. So I thought that maybe voice will be, that's my intuition, although we don't have, in the what we offer, we cannot say that scientifically speaking, but that's the intuition I have.
Mm-hmm. Thank you. I think we have a question by David Ong. If you want to unmute yourself, please.
Hi, thank you. That was a really fascinating talk. I'm just struggling to understand what we as social scientists can learn from these artificial personas. And you mentioned that there was a study that uses a persona to pilot the actual experiment in India. So I wonder if you could clarify what is the gap between the pilot, and what is in theory the gap between the pilot and the actual experimental data. So do you understand my question?
Yeah, so that's an excellent point. So this is completely new. I mean, what I mentioned about this potential of using these models as piloting is basically a kind of an idea, hasn't happened, but the idea is that suppose that these models do give you, somehow reveal latent preferences or behaviors of specific populations. So they can capture somehow that. They could be used for piloting interventions that are really expensive to implement, right? Like if you're having a program social program in an intervention in this is a case of in-kind transfer or cash transfers, you're unclear of what kind of policy you're going to use to help poor people in an area. You could use this as a piloting to have an idea of how they will respond. That's kind of it's kind of an idea. It's just a potential, but it's really you make a good point, which says, okay, what is the truth? Suppose that we look at the study that ethnographic study, let's say the apicella, the endowment effect with the Hadza, and so if we run this with, suppose that our model gives us a different result, which one is capturing the reality? And that's a good question. I think that we will have to do a very systematic study of many tribes and many different experiments to answer that question.
But I wonder if there can be a general answer to the question, because the data that AI is learning from is, I mean, it's the data is a black box, and then the learning process is a black box. I imagine that, one could argue that every instance is different in a way that you don't observe. Do you know what I'm saying?
Yeah.
So it's not clear. It's not clear that the persona is going to be how close the persona is to the actual the data from the actual experiment in any given case.
Right. So in the case that we did for the Hadza, we get pretty close results to the apicella and Henry. So and for the Aceh, again, they didn't do the experiment, so we could just so we don't know. But so again, so it has to be, you're right, it has to be checked whether it can reproduce but if it can't, the question is, is the model wrong or is the experiment wrong that has been done? That's an interesting question. But you're right. I mean, again, so at the end, I mentioned that we could use games to test the models themselves. They are black boxes, and they are like 825 different AI models these generative AI models, that some of them are open source. It's just a wild west, and it's not sure, it's unclear how they work even to the programmers themselves. Right. So one can use our own methods in economics the same ways that we neuroscientists use our methods to clarify what's going on in the brain. We could use, just traditional game theory to kind of to reveal what it is that these models are, or how they think and what they're doing. I think that's a really potential, promising potential collaboration. From the side of how AI can help us, what I presented is intriguing, but I realize it's very preliminary. Yeah, definitely.
So we have time for a last question. Karim Sadrier was the next in the list. Karim, please, if you unmute yourself.
Okay, I hope you can hear me. Thank you very much, Monica. Great talk. No, actually 2 great talks. And I have 2 questions, one for each of the 2 parts. For the first part, I would like to know, you had one voice feature that was correlated to age, you told us. But in the regressions, I didn't see age. I was wondering, how much have you tried out whether actually age is the explaining factor and not the voice? I mean, things like this could be going on. That's my number 1 question. Yes. And the second, if I should add it, I'll just add it and then you can do the talking. My second question concerns the second part. I think that one potential for what you're doing is also to provide sort of hypotheses for tests in the field. So you could use your sort of fictitious personae to provide hypotheses to those who go in the field and start doing field experiments there, because that gives them less of a purely discovering mode and gives them more of a something like a testing mode, because like this you could sort of find this. And adding to what you just said, I also think that if we can find, if we can sort of prove that a specific model and a specific group of data is giving good results in a great number of experiments, then our sort of the reliability of this model will go up for other things that we might be predicting in that field.
Yeah, thank you so much. Thank you so much for the great comments. And yes, indeed, I do believe that age is that if we had information about age, I mean, we could look at the people and more or less put them into bins, 30 to 40, 60 to 70. But we don't have information because this is gathered from a naturally occurring, situation. We don't have age, but I do feel that if we had age, that will explain the cooperation indeed. In the second question, I think that's an excellent suggestion, and definitely that will be a systemic evaluation of the model through a set of experiments, and then identify this is the model that seems to be capturing what's going on. Yeah, that's a really good suggestion.
Okay, thank you very much, Monica. We are at the end of the seminar. It has been a real pleasure to have you with us. A big round of virtual applause. And thank you, thank you to everybody for attending the economic psychology seminars. And just a quick reminder that the next talk in the series is by Catherine Eckel, and it will be on December 11th. Look for your reminders in your mailbox and remember to register for the event. Thank you.
Thank you, everyone.
Thank you, Monica, once again for joining us. And thank you, Carlos and Leo, for organizing once more also. Great. See you in December. Bye.
Bye.